Hello, X-Road community. Thank you so much for having me here. And thank you for sticking it to the end of the session today. I'm really happy to be here and to talk about X-Road security servers on AWS and what are some of the best practices for running X-Road workloads in the cloud. My own personal connection with X-Road goes back quite a many years. In my previous life, I was building solutions that were running on X-Road, that were integrated with X-Road here in Estonia. This was more than 15 years ago. And now I'm sort of circling back, working together with you, with the community and some of my colleagues on bringing the best practices for X-Road workloads on AWS to you. Now, before we go into the questions of how exactly to do something or what to do, we should first touch upon the topic of why. Why is it that customers like being in the cloud? Why is it that cloud computing makes sense? And to start with that, first of all, we need a definition. When we talk about cloud in AWS, what we're really referring to is the on-demand delivery of IT resources with pay-as-you-go pricing over the internet. So because we've had a long week behind of us, let's take a simple analogy, and let's take the analogy of bringing electricity to your home. Really, when you go into your room, let's say your room is dark at home, you flip on the switch, you turn the lights on, and you start consuming electricity. Once you've done everything that you want and you maybe want to go to bed, hopefully being environmentally minded as you are, you will flip the switch again and turn the lights off. And at the end of the day, at the end of the month, typically, you will get a bill and you will only pay for what you used. And it's very similar in the cloud. So what cloud brings you is kind of the ability to make a request, get the IT resources that you need, and you pay them pay for essentially what you've used. Now, this obviously creates a lot of advantages for the end user. And before we go into those advantages, let's take a few steps along the memory lane and talk about how we got here. So Amazon.com was selling books, and we used to only sell books, but at some point we figured that really we want to have a wider marketplace of items, and we grew. And through this growth, we had to grapple with scale. We really learned and we gained this core competency of providing infrastructure in a global and a scalable way for our internal engineering teams. And we decided to start selling excess capacity to our customers because it seemed like something the customers would want as well. And then in somewhere around mid-2000s, AWS or Amazon Web Services was born. We spoke a little bit about the on-demand model and what it really means for customers. And as you can imagine, one of the first takeaways from having something available on demand means that you are able to work more elastically, more agile in the world of infrastructure. It means that you're able to run experiments fast. It means you're able to fail fast if you need to. But this is not the only benefit. This is one of the key benefits why customers choose cloud and why customers choose AWS, but there's also the benefits of a lower total cost of ownership. Thanks to economies of scale, thanks to us being able to service a large amount of customers, what it really means is that we're able to lower the costs for you as an end user as much as possible. But really, when it comes down, what it really comes down at the end of the day is taking away the undifferentiated heavy lifting. What we want to do is we want to take away everything from you, all the undifferentiated work that you have to do to manage your own data centers, to manage your own hardware, to manage your own infrastructure, and leave you enough time and resources to focus on what differentiates you as a business or as a solution provider, as a partner. But these aren't the only benefits. We see that it is greener in the cloud. Based on a research made in 2019, AWS's infrastructure is about 3.6 times more energy efficient than the median of surveyed US enterprise data centers, and we perform the same task with an 88% lower carbon footprint. Most of that carbon footprint comes from, or actually most of the reduction in the carbon footprint comes from really being able to run at scale and being able to utilize servers better, being able to utilize resources better, and to give those savings back to you as a customer. But there's also, of course, the aspect of being able to build more greener or more energy efficient data centers and being able to use energy from renewable sources. Now, when you move to the cloud, it really requires a mindset shift. And to help you shift that mindset and to help you kind of build solutions in such a way that it's that they're cloud compatible means that we've provided for this. We've provided what is called the AWS well-architected framework. So what the well-architected framework really is a set of questions and design principles across 5 pillars. And those 5 pillars are, first of all, there's the operational excellence pillar, the security pillar, reliability, performance efficiency, and finally cost optimization. The thing with pillars is that if you neglect them, it becomes really difficult to deliver functional requirements and at the same time have the system meet those the expectations that you have. But if you follow these pillars, you'll be able to deliver more stable, more reliable systems that are secure and that are easy to operate. So what the well-architected framework really is a mechanism for your cloud journey. You have you do it in 3 steps and you iterate all over again. You start by learning the strategies and the best practices for architecting in the cloud. You go on by measuring. You measure your architecture against those best practices, against your performance indicators, against the metrics that you want to have. And finally, you improve your architecture based on any issues that you found or any new requirements that you have. And you do this over and over again. And eventually, it becomes down to asking the right questions and this sort of a learn, measure, improve cycle. It works in many places because it's really about being inquisitive and it's being about being self-reflective about what you do and asking the right questions from yourself. So first of all, you could start by asking questions about your goals and learning more about your goals. How much do you need to scale, for example? When do you need to scale? When are there peaks in your workloads? When are there troughs in your workloads? What are your cost and reliability targets? Are you willing to sacrifice availability for better cost, or are you willing to, let's say, have more reliability or have less? Let's put it this way. Everything you do requires a good set of balance, and what the well-architected framework helps you to do is it asks you questions. It asks you a question and lets you figure out the right balance for you given your specific needs and given your expectations of the system. You measure, you ask yourself, okay, which metrics matter to me and which metrics matter to my customers, whether I have key performance indicators that matter to me or my customers, or whether I want to follow specific technical metrics. And how do I find out if there's something wrong in my system? How do I react to something being wrong in my system? And finally, asking yourself, what is my process of improvement? When I get these new requirements, when I get to an idea of where I want to be, what are the steps that I need to take? And I think one of the key elements here is that you want to focus on the entire workload, not just the security servers. So we are focusing here a little bit more on the security servers and kind of the best practices there. But when you think of the system as a whole, just having only security servers in the cloud does not make much sense. It probably won't deliver much value to you or your customers. So it's rather about enabling X-Road workloads on cloud that is what we're after. And to help you ask and kind of answer these questions, what we did at the beginning of this year and throughout the summer was we published a set of best practices. They're available on GitHub. You can get the link from the description, the talk description as well. But what it really is it's a set of best practices created with a well-architected framework in mind. And in true Amazonian fashion, 95% of what we do is really driven by feedback from our customers, from you. So we're really eager to get your feedback on these best practices as well. And we've already gotten quite a bit of feedback. So thank you for all your work so far. Now I want to step into a couple of best practices that I think differentiate workloads that run in the cloud from more traditional IT. And this would be starting with the best practice of collecting logs and metrics centrally. So really the idea here is that you want to create a single pane of glass view for your system. You want to create transparency in your system. So in order to have a full view of what is going on in your system, you want to collect metrics, you want to collect logs, and you want to correlate them. You want to understand, okay, if something happened at time A, then what happened at the same time or a little bit later in other parts of the system. And this is why collecting logs and metrics centrally provides this specific requirement or the specific need, how it satisfies the specific need. You can use services such as AWS, Amazon CloudWatch to collect metrics, to collect logs. You can do that using agents that can be installed in machines, in virtual machines that you run. You can do it in a more traditional way of having those logs stored in file systems and then later on collected and analyzed. But the real value there is that you have everything in one place, and that one place can later on be, the logs from that one place can later on be stored and stored for auditing purposes for a longer time. Another best practice is the best practice of using temporary credentials. So a single source of truth for user identity is something that you're after. You don't want to have something like usernames and passwords laying around, or you don't want to have your servers built in such a way, your systems built in such a way that you have, for example, shared credentials between multiple operators. You want to use common credentials. You want to have a single source of truth for the identity, and you want to use federation for the identities. So whenever an operator accesses a system, they get temporary credentials, and those temporary credentials can be then used by different tools. A few other differentiators. So when I'm talking about differentiators, what I really mean is this sort of a differentiation between cloud and more traditional IT infrastructure. And these differentiators are also the ones that made me like cloud. I'm coming from a similar kind of maybe a more traditional IT background. And when I first joined Amazon, I wasn't too big on the cloud idea either. But over time, these differentiators were the ones that really convinced me. Starting from codifying your infrastructure. So whenever you work with infrastructure, whenever you build infrastructure, you can go either two ways. You can set up things manually, or you can set up things through code. And in cloud, codifying the infrastructure, or really putting your engineering talent into practice, taking the idea of what you want to have as an infrastructure and expressing it as code makes a lot of sense. Because at the end of the day, the way how you provision infrastructure is not by purchasing, is not by going to your local store and getting hardware from there, but rather you would take this codified template or the idea of your infrastructure and let services like CloudFormation deploy that infrastructure in code. You can use configuration management. So when we talked about central logging, what central logging does is it gives you an overview of what's happening in your system right now, and what is the sort of a runtime state of your system at the moment. When you use configuration management and you centralize the configuration as well, what you get from there is that you centralize the knowledge of how your system should behave, and kind of the parameters that you want to give to your security servers or the rest of your workload. And by using central configuration management, you have this overview of how you want your system to work. And by using central logging, you get feedback, making sure you can make sure that this is really how the system is behaving. Separating compute and storage is something that is really tricky to do in traditional IT environments, especially when you're not working at a large scale. So the idea here is that in cloud, because everything is sort of natively decoupled, you can scale your computational infrastructure. So for example, your virtual servers separately from your storage. So for example, your block storage or your object storage in the background or your databases. And by doing this, you can scale for different kinds of events, different kinds of workloads. You don't have to scale both at the same time or worry about okay, what happens if my disk space runs out, or worry about what happens if now the server that I bought really doesn't have the CPU power. Integrating testing as a part of your deployment. You have your infrastructure codified, and by having your infrastructure codified, this also gives you the opportunity of deploy multiple copies of that infrastructure. So not only do you need to not only can you test your software and your applications in your environment, but you can also test the environment itself. You can deploy a separate copy of the infrastructure and just run your applications there and run tests against it. Limiting human operator access. We spoke about limiting operator access time-wise. So having temporary credentials, but you also want to have ways how you can limit the need for human operator access to your systems. And by predefining specific actions that the operators can take on your systems, on your security servers, or by having very well auditable ways of connecting to your servers, gives you much more confidence in your security posture. Overall. And finally, of course, selecting the best pricing model. At one point, you will already know, you have a good idea of what kind of infrastructure you have, what kind of needs do you have for that infrastructure, let's say over a period of a year or maybe 3 years. You have a rough idea of how you're going to grow. And when you have this idea in mind, you can start thinking about optimizing the cost and optimizing the bottom sort of a price of your infrastructure. So you can start by thinking, how many servers do I need constantly? How many servers do I need, let's say, maybe on weekdays versus on weekends? Maybe there are specific events that occur in my system that require me to purchase more infrastructure, and you can start then by thinking about, okay, if I have these constraints, if I have those requirements, what might be the best pricing model for me? And some of the best practices address that as well. Now, if any of this felt interesting to you, then I would really suggest and really hope that you would contribute to this project as well. As I said, it's only the beginning. We just started, just launched this best practices this summer. So we're more than welcoming any kind of a contribution you might have. If you go by the link in the QR code, you can visit contributing guidelines on GitHub. You can also take the link from the session description and go from there. And really what we would love to have is a conversation around these best practices and what works for you, what doesn't work for you. If there's anything that you would like to do differently, or if there's anything that we just missed. Please report issues. Please create content requests if you have any. And if you want, you can obviously contribute through pull requests as well, contribute code directly, not code, but let's say documentation directly. And if that's not really your thing, you can ping us on the X-Road community Slack at xroad.global/join. Or if you want to reach out to me directly, feel free to send me an email. That's tonysp@amazon.fi. With this, I want to thank you. Thank you for having me, and I really wish that we will have a wonderful time together creating those best practices, and have a great weekend. Thanks.
And we're back. I'm back on stage. I'm back with Tõnis here, and of course, we thank with Tõnis. We also take the chance to just thank all the speakers who have joined us on stage and those who have joined us also remotely. I think it's great to conclude it with another topic that we have mentioned, let's say, occasionally, like quite a few times throughout the presentations of the day. But then now we get to delve deeper into with, of course, like a representative of Amazon Web Services. So, Tõnis, at this point, I would like to pose to you like a few questions that we got also from the audience, and I'll remind everyone that this is the last chance, let's say, to ask our speakers the questions that you want to be answered. And the most upvoted one has been, what do you think are the most important architectural changes that need to be made to security servers to change them to real cloud-native and cost-efficient applications? I mean, this is a very detailed question. Good job.
Awesome. Thank you so much for the question. I know it's not typically good to say that I really like that question, but I really do like that question because.
I like it too. I mean, I know only half of it that we're talking about, but I like it too.
Yeah, exactly. So there are some dreams or some ideas that I have personally that I think are important. This is my own personal opinion. I would say if there are three kinds of things that we want to do with X-Road, maybe one of them would be something like X-Lakes or let's say X-Road support for data lakes and data analytics, machine learning in general. Another topic would be serverless security servers, that is, or let's call them security serverless, which would really benefit customers and X-Road users who don't have that much, that big, let's say, throughput in terms of requests per hour, per minute, per whatever time. And having this kind of a more serverless approach for X-Road security servers, I think would help a lot in kind of getting this total cost of ownership as low as possible. And maybe the third one would also be IoT support or Internet of Things support for X-Road security servers, so that if I could connect my own sensors in my home somehow, or any kind of an IoT device to the X-Road, that would be super awesome.
Oh, this last thing sounds very interesting. But you mentioned cost, and we exactly have a question about cost, because someone asked, how can I estimate the cost of running my X-Road solution in the cloud?
Okay, thank you. The easiest way, or let's say the most straightforward way, if you have a good idea of what the infrastructure should look like, and you have a good idea of how many servers you have, what kind of storage you would be using. The easiest to do would be to take the AWS cost calculator in case of AWS and put in the numbers, let it crunch the numbers, and you will get a good estimate. But it's not that trivial oftentimes when it comes to workloads that let's say where you need to scale up and scale down in very kind of either infrequent or unpredictable ways. So in this case, if you have something, some kind of a workload, let's say that's very hefty, and you really need help there to cost estimate it, look us up on the X-Road community Slack, or send me an email directly. We can talk about it. But otherwise, if you have a fairly good idea, there are cost calculators out there.
Perfect. And if someone would be interested in starting up with Amazon Web Services, like what what does it take essentially to get started with it?
I think the easiest way or the best way to start is to try and to actually start by deploying a workload. So to get there, you can search for AWS Getting Started, or you can go to aws.amazon.com/getting started. And there you will have quite a nice step-by-step process that you can take, going through the basic introduction to AWS, introduction to cloud, introduction to the well-architected principles as well that we already discussed today, and also step-by-step guides for deploying your first workload. You don't have to worry that much about cost at first, essentially, because there is a free tier available as well. So the first 12 months, you can experiment for a pretty low cost and get a good idea and get a picture of what you want to have.
I guess that in order to decide, let's say, for some change in that sense, we also need to first understand and assess like properly what's the state of our solutions like currently, in the sense this is connected to one question that we got from the audience, which is how can I understand if my cloud solutions are well architected, let's say. How do you estimate that?
So the easiest way to go is by the well-architected framework. And what you can do with a well-architected framework is that once you've logged into the AWS console, you can find a service called the AWS Well-Architected Tool. And what the Well-Architected Tool does is it enables you to create those workload descriptions that you have, and then go through pretty much step by step through all these pillars and answer the questions. This isn't so much a test as it is a sort of a self-reflection and self-assessment questionnaire, and that helps you a lot. And whenever we sit down with a customer and do a well-architected review, we do exactly the same steps. We sit down, we go through these questions, and we answer them, and eventually give out prescriptive advice on how to continue, how to make your workload better. But there's a lot of material out there, and the well-architected tool guides you throughout the way.
We have one last question, which I partly understand, but maybe will tell more to you than me at this point. Because the question says that Docker is good for maintenance, but is Docker also like good for performance, I assume, in terms of, or good performance, it says, for security server with AWS? Do you get the...
I think I get the question, and I wish I had a good answer here. I want to be data-driven, and I want to have data for you off the top of my head for this question. I've always seen containers to be popular for maintenance reasons, as you mentioned, and kind of the idea that you can deploy containers in a much easier way, and you can develop containerized applications in a much easier way. Performance-wise, I haven't heard of any very particular reasons why it should be bad specifically for security servers. But I'm really working and really interested in knowing your experience as well. So anyone in the community, if you have experience, let's say comparing Dockerized or non-Dockerized security servers installations, would be super cool to know any kind of feedback you have.
And also for everyone in the audience, you saw in the last slide that there are your contacts there. So really do not hesitate, like, to just get in touch and reach out to Tõnis. And with this, actually, Tõnis, I thank you for joining us.